All right, let's talk about the sensitivity of the balance. Okay, first of all, this data table here, what you should have found is that when you mass the rubber stopper and the penny, you got different measurements. You probably got different measurements each time, just because our balance isn't sensitive enough to get an accurate, a 100% accurate reading every time, especially when we estimate to the hundredths place. I want to go over the answers to the blue questions. See if I can get them all up there. So the first question says, does your balance give reproducible results? The nearest hundredth, the nearest thousandth, or somewhere in between? I would say it gives reproducible results less than 0.01 grams. And we're going to get to that here in just a second. What's the mass of the large square of graph paper? Well, you were supposed to cut a square 20 squares along an edge, which gives you 400 squares. And they're all going to be a little bit different, but for these purposes, I'm going to say it's about 1.00 grams. Then it says, calculate the mass of a single small square. Well, if we take 1 gram divided by 400, that's the number of small squares we have. That's going to give you the mass of a single small square. So 1 divided by 400 is 0.0025. Then it says how many of your small squares are in a group that has a mass between 0.003 and 0.007. Well, this is less than 0.003. So we're going to have to double this, and that gives us, we take it times 2, it gives us 0.005 grams. So that would be 2 small squares are between 0.003 and 0.005. And what's the mass of such a group? It's 0.005 grams. Now, you may have gotten something different. That's fine. It says now cut 10 of those groups of small squares with a penny rubber stopper already balanced. Add the groups of small squares one by one and observe the effect on the balance. How many groups of small squares did you have to add before the balance gave a reliable response? Most people find that it's about 10 groups of small squares. So 10 groups of 2, 0.005. And so it says the smallest change in mass that a balance can detect is called the sensitivity. So what is the sensitivity? Well, it took 10 of these at 0.005 grams apiece. So if we take 10 times 0.005 grams, you get 0.05 grams. So normally when you talk about the sensitivity of our balances, and they're all a little bit different, but most of them we're just going to say have a sensitivity of about 0.05. So there was one more question you were supposed to answer, and that was number 28. So 28 says, 5 students in turn use the same electronic balance to measure the mass of a small dish. None knew the results of the others. The masses are given in the table below. Can you tell whether any student made an incorrect measurement? No, they're all very, very close together. Do you think there's anything wrong with the balance? I'm going to say no. What do you think is the best way to report the mass of the dish? Well, I would probably find an average of it. Let me go back up to B. Do you think there's anything wrong with the balance? No, and really the reason why is it's just something, it's not very sensitive. It's not sensitive enough to get the same thing every time. Same thing with our balances. We would get numbers similar to this if we massed a small dish. Some people would say it's 4.36. Some would say it's 4.37. If we use different balances, we probably would get very different numbers than this. Okay, maybe one would say 4.30. One would say maybe 4.40. And so there would be some variance there within the balances. But even if we all use the same balance, we wouldn't necessarily get the same exact number. So what I would like for you to do is take a few minutes, and on the left-hand side of the title page here, the one where we wrote 1.8, the sensitivity of the balance, I would like for you to take a few minutes to write a conclusion. Remember, you've got this conclusion sheet taped to the back inside cover of your comp book. Answer all 5 of these questions in complete sentences so that you end up with a paragraph when you're done.